Today I worked on the XOR query problem. It was similar to yesterday, but the constraints were a lot bigger, so brute force wasn't going to work. So I started thinking about optimizations, but I wasn't able to implement it properly. So let's go through what I went and what I tried. Let's see, Leetcode, what do we have today? I think it's what we did yesterday, but a hard one. You are given an integer array nums of length n. For each query, we apply the following order. So now, only thing that's changed yesterday is our constraints are bigger. It's 100,000, right? So we can't use the same length because it's gonna go. Okay. So for each query, you must apply the following operations in order. An integer array num and a 2D integer array queries of size q. For each query, you must apply the following operations in order: set index and the bitwise OR of all elements in after processing. So for each query, so we number of queries are what? Queries start 10, 100,000, right? 10 to the power of 5, that's like 100,000, and same for nums dot length is 100,000, and each element is between 1 to long 1, right? So you are given an integer array nums and a 2D integer array queries of size q, where query, so for each query apply the following. So what do we do? How do we tackle this? For each query you must apply the following operations in order. Let's first have, so for a number of queries could be 100,000, right? And for each query we change the value of num, we update the nums. Oh. Index plus equals to ki, return the bitwise OR of all elements in num after processing all queries. So if we process all the nums, but the thing is, if we do every one by one, it won't accept. So do we split the nums by, see, if we do one by one, it will take time, and one by one time exceed. So we either do in halves where small values are done first, and then we compute the rest values. But how do we decide where? How do I think? So if I have the number of elements are 100,000, right? How do I decide? Set index equals to L, right? And R could be n. Let's initially have integer n equals to nums dot length, right? And queries integer q equals to queries dot size. Dot size and dot size. Queries dot size, where queries, for each query you must apply the following. Or I could do something called query bracket 0 dot queries dot size, or I should do, maybe do queries dot length. I'll think about that later, right? So if I have an array of an array, so that is something like array dot, so I have an array of an array. So if I do array bracket 0 dot length, so that will give me 4. I actually don't even need the size. So we do for each query in queries, and what does a query have? So we do for integer array query in queries. For each element you must apply the false. We set the index. Let's say I set the index, and when I set the num, let's say if I set the num value for one array query teacher index equals to query bracket 0, right? Query bracket 0. So index must be less than equal to r. So we have a range of L and R, right? So L plus index and integer r equals to, index equals to this, integer r equals to query bracket 1. We have a range of idx to r. Maybe optimize here. So let's say if I have a range from 1 to 10,000, right? What's the best way? So final integer mod equals to 10, 1, 10 to 7, right? How do we do? We set the index plus equals to, see, for k is less than equal to b square. What's happening here? Well, the hints that are given is for k, for each index that is less than equal to square root of n. And what is n is the nums dot length. So what do we check? For index less than square root of n, we start looping separate, right? For each contain a difference array of length, seal of then sweep each bucket. What is for k is less than equal to k is less than index equals to l. L is the length of index equals to l. Index do if you if index is first, if we have the index and dot square root of n increased by k and l mod k. I need some help understanding this. So what does l mod k do? So everything that is less than l mod k. We don't actually need to do l mod k for each group maintain different. When index is greater than square root of n, when it's given, when we need to, so aren't we going through the array? Let's see if I can give an integer array nums of length n equation answer what I want in touches. So we either do it halves. How do we decide where is the split based on the k size? Small, so k is less than equal to treat as small step, else large step. Do index, it's k step size. K is because what do you mean by small? K means many updates. Does k control the range, right? Index plus equals to k, so you visit first index and plus k, this is number of updates equals to, so if n is 50 and k is okay, so k decides what index value we accessing dx, right? Let's say k is 100. Let's say we have worst case small k hit. Let's say if I have 10 elements, next step is why all visitor index share the same. When you're ready is why it is index the same. Is it these indexes, right? Now if I take modulo of k, because k modulus k is 0, k doesn't change the and for example is 3 7 now modulus 3, you can go for it. K is not red, it's always outed as specific. Help me solve this. We split the queries, right? Yeah, for each query if our k b is what we actually have here is while variable. What does it? Why do we have a mirror? We initialize mirror or let forces you to. Where does it say? Where is it? I don't fucking see it. Where is Brave Zenith? Where is it? You are given an integer array nums of length 10. Bro, it's literally the second paragraph right after the problem description before the strips. Where is Brave Zenith? I don't get it. See given, right? Here is. I don't see it highlighted anywhere. I don't know. So what we actually have is, so we have nums.length, right? And I want to have an integer b equals to mat dot square root of n. I will cast it because it could be a long. So I will have a long lazy load which is equals to new long array of b plus 1 and b plus 1, right? For teacher which is 0, I must be less than equal to b I plus plus lazy dot fill, arrays dot fill, then lazy bracket I comma 0 or 1. So initially we are filling for query in queries, L equals to query dot q, R equals to query dot 1, K equals to query dot 2, and P equals to query bracket 3. Right. So what we do? We check if k is greater than b. That means we are in the bigger part. We don't need to do much. We do for index L I index, right? I equals to L. I must be less than equal to R. I plus L. What are we doing? We are doing nums bracket index and nums bracket L, right? Nums bracket I or L should be nums bracket I equals to nums bracket I R V. Do I do 1L? Right, make it long and modulus RV modulus. That's correct. Else that means if k is greater than b, correct. And then else we are doing lazy of k bracket L modulus k equals to lazy of k L modulus k star b, whatever value we have over there, mod. Right, and then we do what we set the nums index plus equals to, yeah, bracket I equals to get off value k bracket for integer. So if we go through the nums array for integer I equals to 0, I must be less than n, I plus plus, right? Integer value equals to nums bracket I, and then for k equals to 1, if k is less than equal to b, k plus plus. I don't know what's happening here. Okay, so what happened here initially, we have nums.length, we have the half of the length, and then we initialize another array of size half plus 1, half plus 1, and then we fill this thing with all the ones, and then in teacher for each query set up the required variables, and then if we are over, if k is greater than the square root of, that means we have to do a normal modification of nums I. So nums I is modified for k is greater than b. Else if k is less than b, we do a modification on the lazy thing. And right now nums I is not modified for k less than b. So go through all the nums, right? So we go through all the nums, we set up each value, and for each value k is less than is for each value for value equals to what, n mod value star lazy bracket k, right? Bracket L modulus k and modulus mod bracket I is equal to int of value, and then we have our mains integer or equals to 0. And what are we doing? We are checking if our for our num is for integer, and for each integer in num we do XOR equal to n XOR. Okay, so when k is greater than b and thus k is less than b, we fill the lazy, then we loop the num, and then each iteration of nums we check each of nums we check range of 1, and phase 1 we process queries, right? We process with large k, we directly update nums, okay, but k we do not touch nums, we store the effect in a lazy. So what does lazy mean here? Lazy kr equals to product. It means all queries will step k size that start as multiply by this value. So during queries if k is 3, we store lazy of 3 and 5 modulus 3 equals to lazy of 3 and 2. So group do like heavy compute multiply, then k equals to initialize. So instead of applying queries for each first step size k, update every starting from my. So we start from k to remainder index. What groups? This is index belongs to all the groups. Okay, did just a little bit. I still have to a plus k is greater than b if I plus equals to error and teacher query should be a small r for integer l query 0 if k is small k, bro. For integer I equals to 0, I must be less than n, I plus integer value for long value equals to number bracket I for k must be less than equal to b, k plus plus integer value star lazy k of this modulus mod nums I equals to int of nums. Where is the k? Cannot find the symbol k. Okay, code teacher k equals to 1 to b modulus k and nums I equals to for variable n is already defined in the method. Oh, okay, for integer x I can just do something like, let's if I type in something wrong, go for integer I and the rule says index plus I plus equals to k, right? Correct integer of nums I equal to nums I integer or nums I star l star b. Okay, so it happens after everything is done. Does we okay, but what's wrong? Mistake here, assume all updates. It's not global per. We maintain if k as no, one thing is correct. That's gas cloud. This is what I did. Track the when you do lazy, whatever within multiply. So final teacher array brave lazy. So what's happening here is we have a list of buckets. And no, I don't know. This problem is, oh man, this problem is so annoying. My head's hurting, bro. I'll come back to this later.